Hi, my name is Peter and I'm a developer advocate at Google on the Firebase team. Today, I want to walk you through the process of building a cross-platform app using Firebase and SwiftUI. And when I say cross-platform, I mean iOS, iPadOS, and macOS. You might know that Firebase also works on Android and the web, and that means you'll be able to reuse the backend for those platforms as well. But today, we want to focus on Apple's platforms. All right, let's take a look at the agenda for today. So you can see that we've got a lot of ground to cover today, so let's get started. And let's first talk about how the architecture for a data-driven SwiftUI app might look like. So each year in spring, I take part in a challenge here at Google, which is called a 1 book a week challenge. And the goal is to read 1 book per week for 3 months. Usually I start with a couple of thrillers to get a head start. So this year I thought it would be nice to create an application to help me track my books. And my idea was to build a cross-platform app using SwiftUI and Firebase, something really simple. And here you can see some screenshots of the application running on an iPad, on an iPhone, and on my Mac. And this is what I've been able to achieve in just a couple of hours. And you can see that I've got a list of books. And when you select a book, you'll see its details. You can click on an edit button to make changes. And there's also a plus button, which will open a search UI, which allows me to search for books on the Open Library API. So it's easy for me to add new books to my list. So I know there is a lot of room for improvement in terms of design, but as an engineer, I'm pretty pleased with how this turned out already. So what are the driving factors for this kind of application? So we've got this drill-down navigation, which on an iPad and a Mac results in this 3-column layout. And on an iPhone, this will be a 1-column layout with a navigation stack. And I want all the data to be contained in a single source of truth so that we, when we make any changes in the UI, for example, when we mark a book as read, all those changes will be reflected throughout the entire application. And here is a quick demo. So you will see that when I make a change to a book, like, for example, I update the title, this change will be reflected throughout the application, for example, in the list view and in the details view. And I don't have to tap on save or do anything. Everything is instant and it's live all of the time. All right, let's take a look at the architecture for this application. At the root here, we've got the source of truth, which holds all the books in an array. The book shelf view displays a list of all those books, and it uses addObservableObject to connect to the source of truth. We use a book row view to display a single row in the list, and this view connects to a single book in our list of books. When you tap on the book row view, it will open the book details view, which displays the details of a book. And from there, we can navigate to the book edit view, which displays the book in edit mode so that we can make changes. So we've got this navigation structure, which is indicated by the blue arrows. And we've got this data structure and those data connections, which is indicated by the pink arrows. And you can see that we're using observable object and binding to let the data flow between all those views. And here is a problem. So as you can see, book row view expects a binding to book, but in the list, we iterate over an array of books, not bindings. So, and it seems like we can't turn those books into bindings. Here is the error message that the compiler throws at us. But maybe we can? And it turns out there is a solution for this problem. So instead of iterating over the items, we enumerate the items, and this gives us a sequence of tuples mapping the index of an item to the item itself. We can then use the index to fetch a binding to the item from the array of books. And I agree, it is cumbersome, it doesn't look great, and it's definitely more complicated than the original structure. And there are a number of other solutions that are very similar to this one out there. So ideally, we'd be able to access bindings within a sequence. So Apple, if you're listening, please give us bindable sequences for SwiftUI at WWDC so we can write simpler code than this. And here is another challenge. So the UI updates immediately. And you might be thinking, this sounds funny because didn't I tell you that I wanted it to update instantly just a few seconds ago? Well, yes and no. You see, as a user, I want to be able to make up my mind and cancel my edits by clicking on the cancel button, or to confirm my edits by tapping on the save button. So how can we somehow keep a local state in this view and only update the parent state once the user taps on save? So here is one solution. Let's use an inner observable object. So here we've got the binding so that the caller can pass in the binding to a book, just like before. Then in the initializer, we create a new book edit view model using the wrapped value of the binding. And this is an observed object, so we can bind UI elements to it. Now, instead of binding our UI elements to the original binding, we bind them to the observed object. And any changes that a user makes in the UI will no longer be applied to the original binding, but to the observed object. And that means they're now local. And only when the user taps on the save button will we take the value from the observed object and write it back to the binding. And that's the moment when it will be propagated throughout the application to the parent and the rest of the application. All right, let's see this in action. So you'll see that all my edits are local to the edit view, and they will only be saved to the parent view when I tap on the save button. And when I tap the cancel button, we will leave the dialog without making any changes. So that's much more what we expect from an application where we allow the user to make changes in an edit dialog and then decide if they want to confirm or to cancel. And as an added bonus, we can now use combine to perform some validation logic on our view model. For example, we can verify if this ISBN is a valid ISBN or not. And that was a quick walkthrough of the application architecture. So far, we've only used plain SwiftUI, no Firebase whatsoever. So let's now talk about Firebase. Firebase started out as a real-time database, but it has grown to be so much more. It's essentially a backend as a service platform to help you build better apps faster. Here's a quick overview of all the products it contains. So no worry, I'm not going to walk you through all of those products today. If you're interested, go to firebase.com/products or to bit.ly, what is Firebase. So today, I just want to focus on how to add Firebase to an Xcode project and how to use Firestore to store data. To use Firebase, you first need to create a project using the Firebase console here at console.firebase.google.com. And once you've created the Firebase project, you need to connect your Xcode project. And here is a step-by-step guide that walks you through the process. And on this screen here, we need to provide the bundle ID from our Xcode project. In this step here, we need to download a plist file which contains all the configuration details of our Firebase project, such as the project ID, the API keys, and so on. So we need to drag it into our Xcode project, and my recommendation is to place it just beneath the asset catalog. That's easy to find, and you know it's in the right spot. And don't forget to add this file to all the relevant targets. So this is a multi-platform application. It has 2 targets, one for iOS and the other one for macOS. So we need to add it to both those targets. And next, we need to add the Firebase SDK to our project. And you will be pleased to hear that we now officially support the Swift Package Manager. So to add Firebase to your project, you need to take this package URL here, https github.com/firebase/firebase iOS SDK, insert it into this add package dialog, click next to add it. And then once Swift Package Manager has resolved all the dependencies, we can initialize Firebase. And here is a code snippet that is pretty useful, except that you might notice this won't work for our SwiftUI app. And the reason is the new app lifecycle that was introduced with SwiftUI 2. So let's have a look. Here you can see that new SwiftUI apps no longer have an app delegate. Instead, we have this add main property wrapper, which marks the application entry point. And by introducing this, Apple has made the app startup more declarative, which is really great. But, now it's easier for developers to set up their SwiftUI projects, but how do we initialize Firebase? And the easiest way to do that is to just use the initializer, like this. And this works great for many Firebase APIs, such as Firestore. But for some APIs, such as Firebase Cloud Messaging, this isn't enough. These need a real app delegate. So here is another solution. Use UI Application Delegate Adapter to connect to an app delegate. You can actually reuse your existing app delegate like this one. You just need to make sure to remove the add UI application main attribute. Otherwise, the compiler will complain about seeing two app entry points. Over here in did finish launching with options, we can initialize Firebase, and then to connect the abstract with the app delegate, we use add UI application delegate adapter and reference the app delegate just like so. There's a lot more you can do with the new app lifecycle. For example, you can watch the scene phase to save the current state of the application when it goes to the background, or refresh data when it comes back to the foreground again. You can handle deep links. You can continue user activities. If you want to learn more about this, check out this blog post I wrote a while ago. And that was a quick walkthrough of how to set up a Firebase project and connect it to a SwiftUI application. Let's now talk about Firestore. Firestore allows you to store data in the cloud. And there are many reasons why you would want to do that. Here are two. For example, you might want to share data with other users. For example, if you're writing a shopping list application, you might want to share your shopping list with all the other members of your household, or you might want to share data with your other devices. So in my example, I want to share all the books I have been reading on my iPhone, on my iPad, and on my Mac. So what is Cloud Firestore? Well, it's a document-based, horizontally scaling, NoSQL database in the cloud with real-time sync. Let's look at that in detail. So Firestore has a couple of really cool features. For example, it has near real-time sync, and that means when you make a change, for example, to a field, or you add a new record to the database, all other clients who are subscribed will be updated within, a second or so. It also has offline support, and that means if you're in a spot with bad or no reception, you can still continue using the app and make changes, add new elements, and even delete ones. And once you come back online again, Firestore will synchronize all those changes. If you don't care about real-time sync, you can use one-time fetch. So fetch data once when you need it. So I said that Cloud Firestore is a document model database. That means data is stored in documents, and documents are stored in collections. Here is an example of a document, and it looks a little bit like JSON, but it is more powerful. So we've got those key value pairs here, which we call fields, and those field values can have different types: strings, numbers, binary values, even JSON-like sub-objects like the one that we see here. And those documents are stored in collections. However, documents can't directly contain other documents. but they can point to subcollections that contain other documents which can then point to subcollections and so on. And that means all queries that you make are shallow, and when you grab one document, you only grab that document, not all the collections underneath, which is really useful if you have deep nested structures. So let's now take a look at how the data model for our application looks like. So here in the left column, we've got two top-level collections for the books and the bookshelves. The books collection is selected here. So in the middle column, we can see the contents of the books collections. And in the right column, we see a single book document with all its attributes. So next, let's take a look at how to read this data into our app. So here's the struct that we use to represent a book in our app. And as you can see, it reflects all the attributes of the document on the right. The document ID is mapped to the ID property of the struct, so to make it identifiable. And here is how you fetch data from Firestore. We want to fetch a specific book using its document ID. The first step is to get a reference to the collection that contains the document. In this case, it's the books collection. Here we specify the document ID, and then we use the reference to actually fetch the document. Once we've got the document, we can read the individual fields of the document and then create an instance of the book struct. Let's take a closer look at how we map the document attributes. So we read them individually using the subscript syntax, and that's okay, but quite cumbersome and not very type safe. Just have a look at all those checks and default values. So the question is, can we do better? And of course, the answer is yes, we can. So here's the code again, and now we replace it with this code snippet. The actual code for mapping the document is really short, and it makes use of Swift Codable protocol. And that essentially means Swift and Firestore will now handle the mapping for you. No need to write any code for mapping individual fields. All right, time to review our architecture and see how Firestore fits in. So all we need to do is to update the source of truth and make sure it connects to Firestore. Let's see how we can fetch all books from Firestore. So we use bookstore as our source of truth here. And this published property here contains all the books. Our UI is subscribed to this property, so any updates to this property will be reflected on the UI. So let's first get the Firebase collection that contains all the books, and then register a snapshot listener. This will allow us to receive updates as there are changes on this collection. And whenever there are updates, the snapshot listener will fire and call this closure. Inside the closure, we receive the documents from the snapshot. And then over here, we map the documents using Codable and assign them to the published property. And that means every update we receive from Firestore will be reflected in the UI. Let's have a look how this looks in the application. So in this demo here, we see the Hitchhiker's Guide to the Galaxy, but I think hitchhiker actually is a single word without a space, so let's quickly change that. And you see, once I hit save, the changes are reflected in the UI. Okay, so let's add a book. I use the Open Library API to search for books. Let's add OAuth to an action, and once I add the book, it appears in Firestore, and any change I make to the book in Firestore is again reflected in the application. If you're interested in learning more, check out this blog post about mapping data from Firestore to Swift and back. It covers simple data types, more complex ones like nested dictionaries, dates and times, and colors, and it's really comprehensive, so I recommend reading it. And that was how to integrate Firestore in a SwiftUI application. Let's now look at authentication. Authentication is the process of verifying the identity of a user. And that's actually more than just identification. Identification is the process of indicating a person's identity. And most authentication mechanisms use some combination of knowledge and possession to prove that a user is actually who they claim to be. And we all know this from ATM machines. You need both the card, which is the possession, and the PIN, which is knowledge, to withdraw money. Now, of course, we all know this isn't a foolproof way to authenticate a user. For example, you could give your card to a friend and tell them your PIN, and then your friend would be able to withdraw money from your account. So other mechanisms make use of biometrics, such as your fingerprint or iris recognition, which are much harder to fake or forge. Plus, people are much less likely to share any biometric features with their friends. So Firebase Auth supports a number of third-party identity providers such as Facebook, Google, Twitter, Apple, and we even support email and password and phone number authentication. So once a user signs in with any of these, Firebase assigns the user a user record in your project's authentication database. And that user record includes a unique ID and a signed web token. So no matter how the user signed in, you can always identify them in the Firebase services that support authentication. So how can we add Firebase authentication to our project? Well, there are three main steps. First of all, we need to sign in the user. Then we need to update the data model. And last but not least, we need to secure our users' data. Let's take a look at two authentication mechanisms that are pretty useful: anonymous auth and sign in with Apple. Anonymous auth allows you to create temporary accounts that you can use to give users a warm welcome into your app, so they can start using the app without having to sign in. And once they are happy with the app and want to continue using it, you can offer them to upgrade their anonymous account to a full account by asking them to sign in, for example, using Google Sign In or Sign In with Apple. So I think guest account might actually be a better name for this way of authenticating. And implementing anonymous auth is super easy. You just call sign in anonymously. Firebase keeps the ID token that you receive in the keychain, so the next time a user starts your app, they will still be signed in. Okay, cool. So let's switch gears and see how you can implement sign in with Apple with Firebase. And implementing sign in with Apple is slightly more complex than anonymous auth, as you can see in this code snippet here. Let me walk you through this simplified version of the code required to sign in with Apple. So the user taps on the Sign In with Apple button and is guided through the sign-in process. And once the flow returns from the Sign In with Apple button, this completion block here is called where we receive the result of the sign-in process. In the next step, we extract the credential and then we create a string representation of the ID token. And we then use this token to create a credential using Firebase's OAuth provider. In case you didn't know, Sign In with Apple implements an OAuth 2 flow. Okay, so we've got a valid auth credential now. And in the next and final step, we sign in with this credential. And that's the moment when Firebase creates a Firebase user for the credentials we receive from Apple. And we can use this user account to access the user's data. Perfect. So let's now look at how we need to update our data model to enable multiple users. You will recall that we store all books in one collection in Firestore. But how do we know which user they belong to? So first of all, we need to add a field for the user ID. And we can use this to update our query and filter for all books that belong to a specific user. So we can use the signed-in user, which is here in self.userid. And to keep your users' data safe, you should always implement proper security rules in Firestore. So for example, these rules here make sure that only signed-in users can create new documents, and only owners can create and modify the documents they created. This second rule here makes use of the fact that we wrote the user ID into the document to indicate their ownership. And that was authentication. Let's now take a look at Combine and how it relates to Firebase. Combine is Apple's framework for processing values over time. It follows a declarative approach and makes handling asynchronous code easier. Why is that so interesting for Firebase? Well, most of Firebase's APIs are asynchronous, and asynchronous code can be a little bit confusing. For some of our APIs, it's pretty clear that you need to implement a completion block to capture the result of the call, but for some APIs, it's not that obvious. For example, the current user in Firebase auth here might be nil, even if you just called the sign-in method. So instead of trying to call Firebase APIs in a linear fashion, you should use their completion blocks like this one. But that's cumbersome and hard to read, and you might end up with a bunch of nested calls, for example, if you want to fetch some data from Firestore after signing in. And wouldn't it be nice and much better if we could use Combine with Firebase, like this? We could use the power of Combine to set up pipelines to map data, handle errors, assign results to other publishers, and so forth. And the good news is, you soon will be able to. We're currently working on bringing Combine support to all of Firebase's APIs, and thanks to some great contributions from the community, we've made good progress on Firebase Auth, Cloud Functions, Real-Time Database, Cloud Storage, and Firestore. Check out the GitHub project here for more details. And that was a very brief look at Combine and how we're going to support it in Firebase. Async await is another way to handle asynchronous programming. And to give you an impression why async await might help to write more elegant code, let's look at this code snippet here. So it's pretty hard to read, right? So let me just tell you what it is. It fetches the text of a HTML page, it extracts the keywords, and downloads an image that matches those keywords. This code here does the same, but it's much easier to read. And instead of using a closure, we just use a wait to suspend the current method and wait for the called method to return. And that's what makes it easier to read. So let's take a look at the implementation of fetch article to understand how this works. All right, so here's fetch article. And to wrap our own asynchronous code, we use the helper methods that are provided by Swift's concurrency support. For example, here we make a call to URL session, which is asynchronous. And to handle this, we wrap the code inside a call to with unsafe throwing continuation. Once the asynchronous call finishes, we can resume the continuation. In this case, we return the HTML text that we received. Or in case there is an error, we can throw that error using the continuation. And the good news is that this also works with Firebase. So here we've got the old way of doing things using callbacks, and here is how this is going to look like once async await becomes generally available. And what's most surprising is that since Firebase is mostly written in Objective-C, this works out of the box thanks to the Objective-C interoperability for async and await. So thanks, Apple. We're currently working on making sure that this works for all of our APIs. So if you want to learn more how exactly the Objective-C interoperability works and how you can use async await in SwiftUI, check out this blog post about using async await in SwiftUI and this video about using async await with Firebase. And that was a quick look at async await and how it's going to affect Firebase. Okay, we've reached the completion block. Time to wrap up. So today we talked about architecture and how to set up a cross-platform SwiftUI app that is ready for Firebase. And I showed you how to create a Firebase project, connect it to your Xcode project, and how to install Firebase using the Swift Package Manager. We also talked about the new SwiftUI 2 app lifecycle and what it means for the initialization process of Firebase and other SDKs. I showed you how to fetch data from Firestore and how easy it is to integrate the architecture we chose for our SwiftUI app. We looked at how to sign in users using Firebase Auth and how you can update your data model to make sure that users can only see their own data. Don't forget to write solid security rules. Next, I showed you the work we do to make Firebase compatible with Apple's Combine framework and how this will make it easier to write asynchronous code. And I also showed you async and await, which will probably be released with Swift 5.5 and will make it easier to write asynchronous code. And that's it. Thanks for joining me today, and I hope you learned something new. For more updates, follow me on Twitter, check out my blog and YouTube channel. I'll be on the live stream now to answer your questions. See you in a bit. Hey everyone. So we're live with the Q&A. Thanks for joining me on the live stream. And we have a couple of questions. So here is the first one from Marius. He asks, is the Firebase SDK also for macOS apps? So the answer is we have support for many of Apple's platforms, and there is support for AppKit apps. There is community support for it, and we're working on getting this more stable, and we're hoping to support this officially in short time. Let me see, where is the next question? Okay. How do you make rules to share data for selected users? So when you write security rules, you get access to a couple of things via variables. And one of the things that you get with every request is an information about the signed-in user. So, and this is actually one of the reasons why security rules are a somewhat limited language. So it's not a full-blown language where it can write complete applications, but it is limited to this very specific scope. And there's a bit of echo, so I'm going to keep these out now. One thing that you get in each of the requests is the sign-in user, so you can check the user and then use that in your security rule to look for any documents that match this signed-in user. So in this example that I showed you, we have all those documents, and in the document I had a field with the user ID, so that's something that I specifically wrote back into the document. So every time that a user creates a new document, we will insert the user's ID into this user ID, and then the security rule can take this user ID that you get from the request and match that to the security rule on the document. So whenever you try to read a document, it will try to match that to the user in the request, and if it matches, it will go through, and if it doesn't match, it won't go through. There is a simulator or emulator for security rules in the Firebase console that you can use to check if your rules work as expected, and that's what I would recommend. Okay, let me find the next question. So Bart asks, what were the major changes needed to support Combine from the backend? So it's funny because there weren't very many changes. So I think the biggest struggle that we had was to make sure that we were actually able to test our Combine integration. As I mentioned, Firebase is mostly written in Objective-C, or at least Firebase for iOS is written mostly in Objective-C, and some of the classes were written in such a way that we weren't able to get access to some of the fields that we needed to get access to write those tests. So we tried a couple of things, and in the end, we came up with a way to write fakes to essentially create stand-in objects for those Firebase objects that we weren't able to create and access their private fields. So that was probably the biggest challenge. And other than that, we basically make use of the fact that you can easily use futures and pass-through subjects to wrap your existing code. And if you have a look at the source code in the repository, you will notice that this is really pretty straightforward. So it's almost like pretty repetitive code. So we were able to go through and design this once and then take it to all the different APIs. Not only was it complicated to come up with this idea to write those tests, but actually take the tests that we already have for Objective-C and then transport them over to Swift. That was a lot of work as well, mostly writing work and translating Objective-C concepts to Swift. All right, so next question. Somebody asked, Firebase written mostly in Objective-C. Does it mean it is going to change to Swift behind the scenes? So we have started to use Swift for some of the things. So for example, we have written a view modifier that you can use to attach to your screen and then log a screen viewed event to analytics. And that's obviously written in Swift because there is no way how you can write Objective-C and then write a view modifier in Objective-C. Somebody else from the team wrote a view modifier for in-app messaging. So that's another thing that we did in Swift, and we're doing more and more things in Swift. There is support for Codable, for example, that's written in Swift. We've got support for Codable for Firestore. Somebody from the community contributed support for the realtime database for Codable, and that has just gone in, and a lot more things. So we're trying to modernize and bring things more into the Swift world as it makes sense. But I doubt that we would go in and say, oh, let's write everything from scratch. So it's going to be gradually. So somebody asked about the links. Yes, so I will definitely share links to the slide deck. So I will upload the slide deck to SlideShare and share the link to that presentation. I will also share a link to my GitHub profile, but it's pretty straightforward. So github.com/peterfriese. And I will also make the application and the source code for the application available in a repository. It's just not public yet. Okay, Marius asks, will putting all the data, books in this case, of all users in one collection not make it very massive if you have a lot of users? All right, so this is something that I didn't mention when I talked about Firestore. So one of the really amazing things about Firestore is that it scales really, really well. So no matter how many records you have, or documents, sorry, how many documents you have got in a collection, the speed of the query is not dependent on the number of documents in the collection, but it's dependent on the number of documents in the result set. So let's imagine we would have all the books in the world in one collection, and that's probably, I don't know how many books we have, like let's say millions. So we've got millions of books in this collection, and Firestore indexes all those documents. So it's easy and really fast to select all the books that are from one specific author, for example. And let's say we wanted to look for all the books by Matt Gemmell, which probably is along the lines of maybe 10 or 20 books. I don't know how many books he wrote. And no matter how many books we've got in the collection, this query will always return in constant time. And if we had just 200 books in the collection, this query would return in the same time. All right, next question. Is this app on your blog? Not yet. But I'm working on a book, and it's a sample app for the book. So if you're interested in being one of the first beta readers for the book, drop me a DM and I'll be happy to add you. So Arthur asks, that works for Firestore but not for storage, where I saw the pictures. Okay, so I think the question is, where do the pictures come from? So I actually took the easy route for now because I ran out of time. Originally, my plan was, okay, let me take a step back. So when you tap on the plus button to search for a book, I will go to the Open Library API, and the source code uses Combine as well to handle that, and you'll be able to see that once I share the source code. So I download information about a book that you're searching for, and then I will extract the JSON, map it to a Firestore document, save that document into Firestore, but the image I will not save anywhere. I will just take the URL to the image that the Open Library API gives me and save this URL into my Firestore document. And then when I display the list, I will take this image URL, and I think I use Kingfisher to fetch it and display it. There are some hiccups. It's not perfect. And I think in the long run, my idea would be to store this image in Cloud Firestore, Cloud Storage, so I could pull it from there. That's maybe stuff for the next blog post. Is this code already production ready, or is there another data architecture required? So I think so. Architecture-wise, I think what I showed you in the sample application is an architecture that you can go with. The application as such is far from being ready to ship because it has quite a few rough edges still. But the architecture itself, I think that is something that you can take, and for a simple data-driven application like that, it would work well. If you have a lot more types of data, then you would probably end up with a somewhat more complex architecture where you have more repositories to handle your data, and maybe also when you have an architecture where you need some relationships between pieces of data, that's also a little bit more complicated. Some of that you can already see because we have the bookshelves and we've got the books. So it's a start. But yeah, so I'm confident that you can use this architecture to build a production app. Arthur asks, if you save a date in Firestore and images in storage, do you need different rules? Yes. So you will need different rules for the different parts of Firebase. The language is the same essentially, but yes, it's different rules because the way how you organize the data is just different, right? So you might have different paths in Cloud Storage than you have in Firestore. Okay. Cool. So I think these were all the questions. Thanks for having me today. Follow me on Twitter. Check out my YouTube channel and my blog. And also, because this week is Google I/O, if you still have time today or tomorrow, come join us at Google I/O. It's free to join, no registration fee. Nothing whatsoever, and we've got a really nice virtual adventure where you can walk up to Googlers that you will be able to identify because they've got a little colorful G icon on their avatar, and you can talk to them about anything that you're interested. So we've got a Firebase dome as well, or a Firebase tent, and you'll be able to chat to the Firebase team. Cool. So again, thank you very much. And hopefully in, I don't know, a couple of weeks, couple of months, there will be a time when I'll be able to come and join you in person at one of the next meetups somewhere in the Netherlands. And if we ever come to Hamburg, drop me a line, say hi. If it's possible, I'd be happy to have a coffee with you. All right. Bye.